Okay, so welcome back. In this video, like we last saw, we have now the EKS cluster with the CSI driver and the EKS Anywhere cluster with the CSI driver. Right now is the point where we actually go ahead and deploy SockShop application, which is a polyglot application with a lot of data services which will be persisted over EBS through this CSI, right? And also as a makeup of this application, the front end will be exposed through an Nginx controller with SSL and network load balancer because it's running in AWS cloud, right? So basically we will deploy this, and what you will see as a result is all the pods and all the deployments will come up with the persistent volumes and everything. Plus a NLB will be a network load balancer will be created for the application front end through a ingress controller, Nginx based, right? Okay, let's do this. I'm going to hop over to my terminal here. So now you can see that I have two terminal sessions open. Okay. One is basically targeting at my EKS Anywhere cluster. You can see that this kubectl refers to my context of the EKS Anywhere cluster. And this particular Ubuntu session, the kubectl context is targeted at my EKS cluster. Okay, so it's important to kind of differentiate between the two here. We will work in parallel. Now, in order to deploy SockShop, there is basically SockShop is I've already written a blog about SockShop as such, okay, of SockShop deployment. And we are going to see what the entire YAML file is basically, and I'll just highlight not going into too much detail here, but I'll just highlight the fact that it's a laundry or a long series of deployments that are happening, and they are all merged into a single YAML file. Okay, so you can see that there is a file here, complete demo with persistence, and if I open this, you can see that Redis, the PVC claim for that, the deployment for SessionDB, which is based on Redis here. And likewise, it's about 800 plus lines of configuration. Okay? So you can see that this application is really a monster in that case, in the sense that you have a lot going on in the application as such, right? Point to be noted is that we will go ahead and script it out, the entire deployment, okay? Because when we create the application, instead of manually going through each step and all that, we have basically a script that we will, instead of typing it all over, I can just copy it from my steps.md, so that in case you are referring to this guide, which is under for protect and repatriation, I can go here, steps.md, and you can see from here, okay, yes, and yes. Okay, so you can see deploy SockShop on AWS EKS. It refers to a script, and the script says deploy SockShop on AWS EKS. Okay, so I'm gonna take this particular thing. Firstly, let me see if this file exists on my machine or not. Instead of erroring it out again. Okay, you can see the script exists. It's doing nothing but it's basically creating SSL cert. It's defining a ingress and then creating the SSL cert, and then the secret for the SSL cert, and then finally it's deploying a ingress controller, and then the entire the persistence demo YAML that we saw just now, 800 plus lines. It's basically deploying that manifest file, right? And really creating the ingress resource. So the file does exist, the script does exist on my machine. I just wanted to verify that. Let me take this set of commands and paste them here. Okay, so it's asking me what is the name of the front end. Basically, how will I access this particular the application, right? So the application front end name, we will keep it as sockshop.thecloudgarage.com. Okay. And you can see that the script execution has started. This will take a couple of minutes. Okay. And while that happens, I'll pause the video. So we can see now that the creation of the script has the execution of the script for deploying the SockShop on AWS EKS is done. and with all the various resources required for this application. Yeah, you can correlate this list to the application context that I had shared earlier. You can see that, right? This namespace called as it has 8 microservices, 6 data services, and whatnot, right? So let's just verify this. All this has been created good. We will also verify this in order to be sure enough that this is done. So let's say kubectl get ns. Now note that I'm on the session with the EKS cluster, right? So you can see that there is a SockShop namespace that has been created now. Okay. Now we will quickly get the pod information for this SockShop namespace. So you can see that all the 15 odd pods are running. The cards is a microservice. The cards DB is the backing data service, the database for cards. Likewise, catalog DB, front end, the orders DB, and likewise all the other services, right? And the user DB and all that, right? You'll see the functionality of these services when we actually access the application, and I'll walk you through with a logical functional workflow of the application. We'll see all these services in action. For now, let's also visualize if the persistent volumes have come up, right? SockShop. So kubectl get PVC namespace SockShop. You can see that I've just kind of made it a 1 gig volume. You can create it as 100 gig or more or whatever, right? Depending upon a production setup. Here, although it's 1 gig, doesn't matter. So you can see that cards DB, catalog, orders DB, RabbitMQ session, and user DB, all 6 data services are now backed up by these EBS volumes, 1 gig volumes. Yeah. Storage class used is EBS SC. Yeah, which is based on the CSI drivers for EBS, right? Let's also verify these volumes here. Now we can go to EC2 and see if these volumes are in fact created via the EBS service actually, right? While that happens, network is a little slow. That's okay. While this happens, we will also verify if the ingress has been created. Ingress would be actually to ensure that I can access the front end, right? So you can see that the ingress controller Nginx has exposed the service, and it is available via this network load balancer URL. You can see this URL, right? That belongs to a NLB from Amazon actually. So if I hit this NLB, I should be actually reaching this particular the SockShop application actually in that case. But I will not hit this directly because this is mapped to a domain name, because the SSL certificate associated with the SockShop application is to a DNS name, right? SockShop, the cloudgarage.com. So we will hit that, and I will have to kind of map this particular address with the DNS name there, right? So I just want to make sure that you understand what's going on from an ingress standpoint, from a PVC standpoint, from a pod standpoint for the application here. Let's also go to EC2. I apologize for the delay. The network is not in my control. Let's click on volumes. So you can see that right now I can see that there is the EKS node, which has its own 16 gig of root volume, and the 6 volumes have been created dynamically by the EBS service based on the PVC that we actually saw. You can see that each one of them has a 1 gig capacity. It exactly matches with I just want to make sure that you understand and get it from that perspective. kubectl get PVC -n SockShop. Again, I'm just repeating this. You can see that this 6 volumes, then these 6 volumes here, right? So now, at least from a console and from a kubectl, you can see that the application has been fully rendered on the EKS cluster running inside of public cloud. You can also view this information. I know the network is behaving a little slow, but let's go here. You can also easily kind of go and verify this information from the EKS console itself, where if we dig into the console further into the resources and things like that, you should be able to see all this information. So let's just go here. And if I go to the resources, and I can see the pods here, and I can list the namespace here, and I can see that this namespace is now seen in the console also. And I can see all the information that you saw via kubectl. All this is available here, right? So that brings us to I'll just pause the video a little bit, and I'll go ahead and do a DNS mapping, and then come back. Okay. Okay, so Raghav, now what we'll do is we have verified the makeup of the SockShop application through the EKS console and also the kubectl. Now it's time to kind of get familiar with the application workflow as such, right? Because what we need to do is we need to preserve the state of the application, right? It's not just moving the container definitions, because stateless applications, as the containers may be, it's just a set of YAML files, right? You deploy it on one cluster. I mean, those images will be deployed in the pods and all that. You deploy in another cluster and the same guy. It's stateless. But here, the SockShop application, as you can see, is not a stateless application. It has a lot of persistence requirement, actually, from the fact that there are databases running and whatnot, right?
Yeah.
And databases are presently empty. Most of it, basically, the application does not have any valid data to actually, migrate the state from A to B, which is from EKS to EKS anywhere. So we start using the application workflow to generate the data that will represent the state of the application. Okay, and doing so, what we'll do is we'll create a user, we'll place it's an e-commerce portal of sorts. So we'll place some orders, and then that becomes the definitive scope for migration, right, of the application with its state preserved actually from A to B. Now, let's observe that the front end of the application is available through this NLB. Okay, so I'm going to take the NLB and derive the IP address for this for easier DNS resolution. I'll take the IP address of this. Okay, you can see this is the IP address for the NLB here. And I'm going to edit my local host file. I don't want to go into the DNS server and make changes. It will take a little bit of time. So, and I'm going to put this particular SockShop, the cloudgarage.com map to this particular IP address, 182.169. And 182.169 is going to be mapped to SockShop.thecloudgarage.com, and that actually then translates into the NLB here, right? You can see that this is the mapping here. So now what we'll do is, since this is now the DNS entry or the host entry has been created here, I'll just save my local file here, go and try to ping SockShop.thecloudgarage.com, so that we can ensure that we are hitting the right target, right?
Yeah.
Okay, so you can see that this is the IP address that it's reaching.
Yeah.
And we will also verify that this is the same IP address when we ping the NLB.
Yeah.
Okay. So I'm gonna ping.
Yeah, the same IP there.
This is the same IP address. So now when I hit this, I know I'm going to go through this NLB onto the ingress controller and then the front end of the application here. So let's quickly go to, open a browser window here, and I'm gonna say HTTPS SockShop.thecloudgarage.com.
There you go.
The first thing that you notice that we are presented with a SSL warning. So this is a self-signed certificate for the domain, which is a part of the secret configuration in Kubernetes, right? It's mapped as a secret SSL certificate. So the browser is asking me to validate this, and we'll continue. Here, we could have a valid certificate, but that's out of the scope right now. Now, the first thing that you see is a homepage. Okay, and this is a e-commerce portal for, I hope you like some of these socks. Not that I can ship them to you, but the fact
definitely colorful. Yeah.
So we will register. So when I click on register, obviously, the first thing it asks me is a set of, basic inputs. On doing this, we are actually activating the user service, the user microservice. Yeah. And when we populate this particular user entry, it's actually going to populate the user database there. So I'm just going to kind of, type in a few details. let's say the cloudgarage.com, and some password I can remove. You can see the registration is successful, which means the first microservice and the backing database, the user DB, is working, right?
Yeah.
I hit on to catalog, okay, and I get a set of catalog items and all that, right? So this is the catalog microservice and the catalog DB, okay. So that's the second constituent of the entire application here. Now, when I have, let's say, a typical add to cart, right? So this is the add to cart, means the cart service is being activated and the cart's DB has been populated. So you can see that I have one item in the cart there, right?
Yeah.
One item in cart. So
yeah.
This is the third microservice and third backing database. When I go to the cart here, you can see that my shopping cart is, so this is also coming from the cart service, right? I have to fill in the shipping address and the payment details. We'll put in some mock data here. 1, 2, 3, 4, A, B, C, D, whatever, we can, let's give Bangalore, or it can be anything else, 560001, and okay. So when I do this, again, it is actually hitting my user, database, and payment I'll update, saying 1111, 1111. Okay, this is a mock application. So you can see I've just updated. So these are all indicative of the state changes of the application, right? Some databases, some data entries are created in the backend and all that.
Right.
Now I go to the proceed to checkout tab here. And when I do that, you can see that, my orders are reflected. This is the order which has been placed here. The status is shipped and the action is there. And I can see the totals and all that. Now I can see the order in an elaborated detail. Let's take a note of this order ID 55C0D.
Yeah.
When you migrate the application from EKS to EKS Anywhere, two things should happen. I should be able to log in with the same user that I just created. Actually, before that, when I log in or open the browser, I should not have to re-accept the SSL certificate. Because the same SSL certificate should be migrated from EKS to EKS Anywhere for my application front end, which is SockShop, the cloudgarage.com. If I'm presented with a new SSL certificate, we know that the SSL certificate has not been migrated, which in turn means that the TLS secret associated with that certificate has not been migrated as a part of the metadata. The second thing that has to happen is that the user, and the user state has to be kind of migrated as a part of the application, which means I should be able to log in without re-registering and all that. The third thing that should happen is that when I get into the user and I click into my account, I should see this particular order ID in there. That would fully establish the fact that the entire state of application with the metadata is kind of migrated from a EKS cluster to EKS Anywhere cluster. Okay.
All right.
So let me just log out from here. 655C0D. Okay. That's the order ID that we will have in reference. Okay. Now, this finishes the deployment of the SockShop application
on EKS.
Okay. And I showed you that we verified this through kubectl and also the the EKS console, right? And the cluster as a set of resources. In the next video, what we will now do is prepare for the main component which will help us migrate from A to B, which is the data domain virtual edition, which is the target backup target, right? And the Power Protect Data Manager. The Power Protect Data Manager, in the previous video where we had done one of the blogs for SockShop, it's already there actually how the Power Protect Data Manager was set up. So I'm not going to recreate the Power Protect Data Manager. I already have an existing installation of Power Protect Data Manager. We can refer to the previous video. What we are going to do is actually set up the data domain virtual edition on AWS and then integrate that with my existing Power Protect Data Manager so that the two can actually function in unison of sorts actually. Okay. See you in the next video.